An interesting take on the equation of a tangent to the circle here. We're actually being asked for this value here, p. I think the best thing to do is to just treat it like a normal finding the equation of a tangent question. How do we do that? Well, we need to remember a crucial thing about the circle, and that is that this line here is perpendicular to the tangent. The radius, line of the radius, is perpendicular to the tangent. How does that help? Because we know if I see this minus 12, 16, I can draw a little triangle coming down, and I can see that I'm going. Actually, I know the point is minus 12, 16. I like to generally say that it's minus 16 down and 12 along. So I like to go from like left to right. So I'm going down, I'm going to the right. It doesn't matter too much if I put minus 12 and 16, but I'm just telling you I'm doing it that way. And then the gradient of the radius, actually it's the gradient of the normal. So I'm going to write normal. You don't tend to see this too much at GCSE. I'll put radius in brackets. That's going to be rise over run. It's going to be minus 16 over 12, which I can cancel down. It's got a common factor of 4, minus 4 over 3. So, how does that help? The gradient of the tangent is equal to 3 over 4. Whoa, where did I pull that from? So you've got to remember that for perpendicular gradients, m1 times m2 is equal to minus 1. Not going to prove that here. That's something that you should have seen previously. Basically, you find a negative reciprocal. You flip it round and you find the negative of it. And that's something you need to know for perpendicular lines. So where does that leave me? That leaves me with the tangent. I've got remember, y equals mx plus c for a straight line. So y is equal to 3/4 x. It's the gradient times x plus c. Okay, I'm getting there. I can now use this point here. I can substitute that in because it lies on the tangent. So I can write down the value of y. I can substitute 16 in. 16 equals 3/4 times minus 12 plus c. And that means, what is 3/4 of minus 12? Well, 1/4 of minus 12 is minus 3 because it's minus 12 divided by 4. So 3/4 I times by 3, I'm going to get minus 9. And then we get that c is equal to 25. And I have the equation of my tangent if I want it. Actually, the thing that I wanted was this value here. This value of c is the value of p. It's my intercept. And so I've basically found it. I don't need to write any more except that p is equal to 25. Just want to say a little bit more because I know I went through that quite quickly. Like, I'm assuming that you've seen this question before. The fact is you need to be aware when you have a tangent in a circle, the relationship between the tangent and this normal line. The gradients, you need to know this property. You need to know y equals mx plus c, which I didn't actually write down. You need to be aware that you find the gradient of the tangent and then you substitute in for c in general. And then in this particular case, it happens to be the value we're interested in as well, where it crosses the y-axis.